Hi everyone, I want to introduce what is the vector data analysis. The vector data modes use the point and their xy coordinate to constitute the spatial features of point, line, and area, which is polygon. Those spatial features are used as the input in the vector data analysis. Next, the unions and the intersect work with both features, which is geometrics and attributes, to represent the outlet. Then, what is the outlet? An outlet operations combine the geometrics and divisions of the two features layers to create the output. And we see the button here. This one is geometrics, this one is attributes. We combine together and we get the output here. Just now I introduced what is the vector data analysis. Now I will introduce what is the raster data analysis. The raster data mode use a regular grid to cover the space and the value in each grid cells to represent the characteristic of a spatial phenomena at the cell locations. Here you see the picture here. Actually, this picture came from the satellite. You can see the Earth pictures here. After that, the other side is actually the grid cell. It's got a number here.
Line and area that is used in GIS. Line data is used to represent linear features. Common examples would be rivers, trails, and streets. Line features only have one dimension and therefore can only be used to measure length. Line features have a starting and ending point. As you can see from here, these are the example on x and y coordinates. Each vertex has a line that connects it to a path. Essentially, you join these dots in a specific order to form a vertex line, with each dot representing a vertex. And these are the example of ski lifts. And these are the example of line in area that we can view in the raster data. Second is area on area. It is a closed two-dimensional shape defined by its boundary or by an adjacent set of raster cells. A calculation of the size of a two-dimensional feature measured in square units. Storing each arc only once reduces the amount of data and also ensures that the boundaries of adjacent polygons don't overlap. And as you can see from here, these are the example on x and y coordinates, and these are the example that we can use to make a forest, maybe boundary or states. As you can see here, these are the example of area on raster data.
For point and polygon, as mean zero dimensional abstraction of an object is represented by a single x coordinate. A point normally represents a geographic feature too small to be displayed as a line or area. For example, the location of a building, location of small scale map, or the location of a surface cover on a medium scale map. In most cases, the concept of latitude and longitude along with a spatial reference frame when there are not enough polygon to depict the characteristic. The term point is used for instance for example population, housing, and so on. That's for point. If we look at that at my finger point, which example like this, town, point of interest, capital ground, symbol like this. Okay, like polygon, feature used to represent areas. Polygon is defined by the line that make a boundary and point inside its boundary for identification. Polygon has attribute that describe the geographic feature they represent. Okay. When you link a set of vertices in a specific order to make a polygon, you have created a vector polygon. They will link and they closest. Okay. Polygon at my left, and it's for example like state, country, and borough. Okay, for example like this, yeah.